Hai, Assalamualaikum. Nama saya Siti QAMARINA LIYANA binti MOHAMMAD bernombor matrik S59667.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad AIMAN bin DASUKI dengan nombor matrik S60246.
Assalamualaikum warahmatullahi wabarakatuh. Saya Nur Aliaa binti Razak S60127. For our group, I will be the presenter of the report. Our group have chosen an article about hyperthemia that happened among the children in United States. According to the article, it is about child hyperthemia death in closed car. In general, hyperthemia is caused by the lack of sweat glands to regulate body temperature. Certain groups, such as active individuals and soldiers, are at risk due to the high heat conditions. A study analyzed the medical records of over 80,000 elderly individuals in the US from 1991 to 2006. It revealed that the elderly was prone to experiencing heat exhaustion due to their lack of training in how to maintain their cool temperature. For our problem statement, we talk about why it is mostly happen among the children. So, we decided to find mathematical model of our own by using the rate of fluid loss from a body depending on its surface area. This can build a logical mathematical model on how hyperthermia can make children die but the adults still remain alive. The objectives of our reports are: first, we want to find the mathematical model on the real-world problem. Then, we want to predict the cause of hyperthermia cases that occur using a constructed model. Lastly, we want to compare the predicted data with the expected data. From the problem, we can formulate a model. To formulate the model, we have to identify the real problem. First, we need to develop a formula for the amount of fluid loss, which is dependent on a few factors, which is first, volume of fluid in body, outside temperature, time, rate of fluid loss, amount of fluid loss, surface area exposed, and part non-exposed. So we can formulate a mathematical model which is rate of fluid loss equals to surface area exposed over time. Thus, the surface area that not exposed may be as width in unit m. So, we can find the amount of fluid loss with the formula of rate of fluid loss times with width times with time. So, we can find the amount of fluid loss in the unit of m cubed. In our research, we will be using a block as an assumption over a human body for our model. The surface of the block are labeled with A as top and B as the front surface. The width of the block was also included in our calculations for surface area exposed. There are a few constant variables like 60 seconds for time for rate and 1800 seconds for time span left. To see if there are a relationship between different age and probability to die, we assume that the amount of fluid in body is proportional to volume of body. From the block that we built, we can now obtain the mathematical solution. First, the amount of fluid loss will be calculated in two cases. First, consider the exposed surface area for which the top and the front. For the length is 5 meter, width 2 meter, height 3 meter. Time for rate is 60 seconds. Once we have the data, we can substitute in the linear equation that we built, which is rate of fluid loss equals to 2 times height times length over time. To interpret the mathematical solutions, we construct three cases with different temperature to see what will happen with the amount of fluid loss. For case 1, we decided to choose 0 degrees Celsius, 80 degrees Celsius for case 2 and negative 80 degrees Celsius for case 3. Then we substitute the value into the formula VL equals to FR times AR times cos theta times TR. For case 1, we get that the volume of fluid loss is 3,600 meter cube. For case 2, the amount of fluid loss is 622.1334 meter cube and 625.1334 meter cube for case 3. So we have the data of length, width, height and time flow rate, and the time flow rate is remain constant. Then we substitute into the formula, which is A equals to length time height time width time 2 over time flow rate. So we have the result of fluid. So we have the result of rate of fluid loss is 0.001 m cube per second, and the time span left is 3,600 seconds. From the actual data, the outside temperature, which is theta, is in degree Fahrenheit. So we change the degree Fahrenheit into degree Celsius, which is 83.4 degree Fahrenheit equals to 3.37 exponent negative 30 degrees Celsius. So we substitute all the data into the formula y equals to fx cos theta plus tl. So we get the value of y equals to 3,600.0001 m cube. For the result, here we can see that the data of child hyperthermia death in closed car in United States. By viewing our actual data in table 1, we want to find the equation that have highest R squared. So we use some helps on Excel software, and we found that the linear equation is somehow looks more satisfied. In order to simulate it with our predicted data, so we create our own mathematical model in linear equation, so it will be easier to be done and compare. Actually, for our problem, we use Excel and Maple software to compare our predicted data and actual data. Then, we relate our comparison with some factors that might be the answer for our question in problem statement and finding the relationship between them. To clear out our result, we back to the main objective that we want to achieve, as well as to find the answer for our question in our problem statement. This is the graph of our predicted and actual data. In Maple, we get to construct one graph of predicted data and one graph for actual data, while we use Excel to find the value of R squared for actual data. The more the value, the more it is valid. Actually, there is another value of R squared which is bigger, but we use this value because it is easier for us to compare the actual and predicted data, which is also linear equation. That's all from our group. Thank you.